In section 2.1, we're going to be working with combining like terms. So a couple definitions here to get us started. So the terms in an algebraic expression are going to be the parts that are separated by addition. Coefficients are going to be the numerical factors or the numerical part of the term. A constant term is going to be a term that only has a number, so no variable. The factors of the term are going to be the parts of each term that are being multiplied together. So remember, factors are things that multiply to other things. And kind of the big one here is like terms for what we'll be doing in a second. Like terms are going to be terms that have exactly the same variable factors. So what that means is they're going to consist of the same variables raised to the same exact exponents. So why this is useful, what we're going to be doing is we're going to be combining them. So we'll do that in a little bit. But for some examples of these like terms, something like 7x and negative 2x. So we say that these are like terms because they both have a variable factor of an x, and both of those variable factors of x are raised to an exponent of 1. So they have the same variable raised to the same exponent. They have different coefficients, coefficient of 7, coefficient of negative 2, but same variable factors, so they're like terms. Okay, so something else like 4y squared and y squared. So those are also like terms. They both have the same variable factors of y to the second power. First one has a coefficient of 1, second one has a coefficient of 2. And for another one here, say we have negative x, y, and 3xy. So those are like terms also. They both have variable factors of x times y with an exponent of 1. Coefficient on the first one is a negative 1. Coefficient on the second one is a 3. And for the next one, obviously we can have more than two things have like terms, so I'll do this next one with more than just two. So let's say we have x squared y and negative 5 x squared y, and I'll throw in a third one here for this one, and we'll do 10 x squared y. So those are also like terms. They both have, or all three of them have the same variables, factors with the same exponents, x squared times y. Okay, so those are all examples of like terms. So let's do another example before we start combining them. So given this algebraic expression, we have x squared plus 4x plus 5 plus 7x minus 2x squared. Let's answer these questions. So first one, how many terms are there in the algebraic expression? So terms are separated by addition. So we have, I'll highlight them. We have 1, 2, 3, 4, and 5. So we have 5 terms here. So you may be thinking, well, you just said it was separated by addition, and the last one over here is clearly subtraction. So we could actually rewrite that if we want. We could rewrite that as, instead of minus 2x, plus a negative 2x squared, right? Or sorry, instead of minus 2x squared, we can rewrite that as plus negative 2x squared. So subtraction can be thought of as addition, except we're just adding the negative. So it's essentially the same concept. Okay, next question, what's the coefficient of the first term? The first term is x squared. Erase all that. The first term is x squared. So if nothing is written there, that means it is 1 times x squared. It's 1x squared. The coefficient is a 1. Next one, coefficient of the last term. So the last term is negative 2x squared. So that means the coefficient is negative 2. So just don't forget that negative sign. The constant term, so the constant term is going to be the term without a variable factor. That's going to be that 5 right in the middle. There's no variable on it. So the 5 is going to be the constant term. Next one, what are the like terms in the expression? So like terms we have for the first one, the first term is x squared. the last term is negative 2x squared. So that's going to be x squared and negative 2x squared are like terms. Oops. And so we have a 4x and 7x are like terms. Okay, and then for this last question here, we have what are the factors of the second term? The second term is 4x. So the factors are the portion or the parts that multiply, that are being multiplied. So this is 4 times x. So that means the factors are 4 and x. Okay. So let's get into combining like terms. So just as a reminder, even though we've said it a million times already, like terms are terms that have the same variables and the same exponents on those variables. Okay, so that's really important for combining like terms. Like terms are the only terms that we can combine when we're adding or subtracting. So what we're going to be doing is technically it's the distributive property in reverse. So before, when we were doing the distributive property, let's say we had a plus b times x. We would distribute the x in, so going from right to left here, and it would be ax plus bx after we distributed the x. Now we're going to be going in the reverse direction, and it's actually called factoring, which we'll get to, and we're factoring out the x and combining the coefficients. So let's see this first example. Combine like terms, we have 4x plus 15x. So once you're comfortable with this, you can go right ahead and say that's going to be 19x. You have 4 x's, you are adding 15 x's, so that's going to be 19x. What you're technically doing behind the scenes here is that distributive property in reverse and saying that's going to be 4 plus 15 and then times x. 4 plus 15 is 19, so 19 times x, so 19x. Okay, and then the second one here, 7a minus 2a. Once again, you can skip right to saying, well, you have 7 a's. You're subtracting 2 a's, so we're left with 5 a's. But technically, what you're doing is you're saying that's going to be 7 minus 2 times a, which gives us 5a. So both of these examples just had these two terms in them, and they were both like terms. So it won't always be that way. It's going to be more complicated. If we have 3 or more terms, what we're technically going to be doing is using that commutative and associative properties to group these like terms. So let's see, for example, let's say we have 7x plus 5 plus 3x plus 8. So for combining these like terms, what we're going to do is say this is the same thing as 7x plus 3x and then plus 5 plus 8. So we can rearrange that, right, based on the commutative and associative properties of addition. So once we have it like this, 7x plus 3x, they're like terms, that'll give us 10x. 5 plus 8, that'll give us 13. So we combined like terms and got 10x plus 13. For this next one, we have 4x plus 7y plus 2x plus 3y. So we can rewrite this. We can put the like terms next to each other to help us out. 4x plus 2x plus 7y plus 3y. 4x plus 2x is 6x, 7y plus 3y is 10y. Okay, so I'm going to be skipping that intermediate step, and I'm just going to be going right to the answer when we have it like this, and I'll just kind of cross them out as I'm doing it so we know I'm not missing one. But just for this page here that we just did, know that this is going on behind the scenes. It's the distributive property kind of in reverse, and then it's using the commutative and associative properties of addition. Okay, let's get into the actual examples here. So simplifying algebraic expressions. So an algebraic expression is going to be considered simplified when there's no more parentheses and the like terms have been combined. So what this essentially means is distribute, combine like terms. So pretty sure we're going to be doing that for all of these. So let's do this. Let's do this first one here. So 5 times 3x plus 7, and then plus 6x. So we have to first distribute the 5. So when we distribute the 5 times 3x is 15x, plus 5 times 7 is 35, and then plus that 6x afterwards. So we have 15x plus 6x. I'm not going to rewrite it next to each other. You can if you want, but recognize those are like terms. 15 plus 6 is 21. So 21x plus 35. Okay, so now it's simplified. No more parentheses. Like terms are combined. Next one, we have 8x plus 2, and then we have times 5 minus, and then parentheses again, x minus 3. So we have brackets. So remember, brackets are just parentheses, but we use them when there's parentheses within parentheses, so there's not too many parentheses. So for this one, I'm going to go into the bracket and simplify what's in there first. So I'm going to actually distribute this negative. And remember, that's a negative 1, right? If it's just negative, it represents negative 1. So I'm just going to rewrite the first part, 8x plus 2, bracket, times 5. So distributing a negative 1, that's going to be minus x, and then the 3 becomes positive. Negative times negative becomes positive. So now combining the 5 minus x plus 3, you have to be a little bit careful here. The minus sign, the negative, is on the x. So when we're combining the 5 and the 3, it's 5 plus 3. So it's 8 minus x. So what I'm going to do actually right here, I'll actually leave those brackets. You could rewrite those as parentheses right now if you want. You could have done it in the first step also. Doesn't matter. I'm going to distribute this 2. So distributing the 2 times 8 is 16. 2 times negative x is going to be negative 2x, so minus 2x. Combining like terms, 8x minus 2x, those are like terms, we get 6x plus 16. Parentheses gone, like terms are combined. Okay, and then for this next one, for C, 6 times 2x plus 4, 2x plus 4y, plus 10 times 4x plus 3y. So we're going to have to distribute twice. We have to distribute the 6, and then we're also going to have to distribute the 10. So distributing the 6 first, 6 times 2x is 12x. 6 times 4y is 24y. Plus, so now distributing the 10, 10 times 4x is 40x. 10 times 3y is 30y. So for combining like terms here, we have an x term and a y term, and we have 2 of each of those. So we have 12x plus 40x. That's going to give us 52x. And then for the y term, we have 24y plus 30y. So that's going to give us plus 54y. So when you're adding with these exponents, with the like terms stay exactly the way they are. The variables stay exactly the way they are. You're just adding or subtracting the coefficients. Let's do several more, make them a little bit more complicated. So we have for D, negative, and then in parentheses, 3x squared minus 4x plus 3 times x minus y plus 2x squared minus 5y. So as soon as you see that big grouping of 2 parentheses, you know we're going to have to distribute twice. So first, we're going to have to distribute the negative 1, and then we're going to have to distribute this 3. So distributing the negative 1, negative 1 times 3x squared is negative 3x squared. It's just going to negate everything. Negative 1 times negative 4x becomes positive 4x. So next, distributing the 3. 3 times x is just 3x. 3 times negative y is negative 3y, so minus 3y. 3 times 2x squared, so plus 6x squared. And then minus the 5y. So looking for our like terms here, we have an x squared term in the beginning. And then we have a 6x squared term towards the end. So negative 3x squared plus 6x squared. Negative 3 plus 6, that's 6 minus 3, so that's 3x squared. And we have some x terms. So we have 4x plus 3x. 4 plus 3 is 7, so 7x. And then we have a couple y terms here. We have negative 3y minus 5y. So negative 3 minus 5 is negative 8, so negative 8y. Okay, and I think this is the last one. Yep, last one right here. We have 3 times a squared plus 4a squared b minus ab squared plus a squared minus 6 times a squared b minus ab squared. I think I said all that correct. So we have 3 big sets of parentheses here, so we should be expecting to distribute 3 times. First, we're going to distribute the 3 to both terms. Then we're going to distribute the negative 1 to both terms in the next one, and then the negative 6 in the third one. So distributing the 3 in the first one, 3 times a squared is 3a squared. 3 times 4a squared b is plus 12a squared b. So first one done, 1 out of 3 is done. So next one, distribute the negative 1. So it becomes minus ab squared minus a squared. Last one, distribute the negative 6. So be careful when you're distributing negative 6. Make sure you are distributing the negative also. So distributing the negative 6, we get negative 6a squared b plus 6ab squared. So the negative times the negative made it positive for that last term. So this one's obviously a little bit more complicated, right? So let's look at the first one. 3a squared. We have another a squared term right there. So we know we're going to get 3a squared minus a squared, so 2a squared. For the next one, we have 12ab, or 12a squared b. So it's an a squared b term. We have another a squared b term right here. So that's going to be 12 minus 6, so plus 6 a squared b. And then for the next one, we have a negative ab squared. We have another ab squared term at the end. So that's negative 1 plus 6. So that's plus 5, and then 5ab squared. So if you underline them with different colors, like I just did, obviously it's easier for me because I have the little draw kit up top, or cross them out as you go. Just make sure you have them all, which we have them all accounted for. All terms are combined, so we are all set. Okay, so that is it for section 2.1.